will show you how to extract more value from research data and our experience. First of all, thanks to Elsevier for choosing Spain and this fantastic city, Valencia, the seashore of the Mediterranean. We see pure CRIS as a data hub, and everything has a code name. Our code name in Universitat Autonoma de Barcelona is Egreta for that product. We see Egreta as a hub to ingest from several sources, as you know, and also we use Egreta for extractions, for example, for the corporate data warehouse or the regional research portal using the ways they give to us. But there is a third way that we have chosen, and we are very proud of it, that is to have a replication of the relational database. Our strategy is to use the API to understand the structure of the data and build a relational database. This was a success, and we are very proud of it. And we also gave it a code name, Kraken, because it has lots of arms to do lots of things. For example, this application feeds, this database feeds lots of mini applications to do several functions on our research area. Let's do a deep dive on our replica database. We understand how works the API 5.24 and did a reverse analysis of the structure of data that comes from the API and replicated it in a relational database. It was very interesting to do it, and it works like a charm. It runs very well, and now Pure and Kraken are now both sources of truth. They are synchronized every time we want. We do in a 1 hour pace, and it gives extraordinary results for us. We are aware that the API is changing, and we are doing experiments with the new API about JSON, not XML structures, and it works also very well. Let's do a bird's eye view. This is not readable, but for any of you, you can see the research outputs table and identify what you are dealing with your API experiments that reflects exactly the API response, the structure of the table. The idea now is at Kraken and online transaction processing databases to our data pipelines. I will show you 3 use cases that gives us the clue for the rest of the presentation. On the 2 rows, gray rows, we see how we understand how works the pure user interface and the pure application. It works very well for atomic usage on a daily basis, and the user works, and it has a very interesting response time, that about 1 second. If you ask to do more work to the pure interface, the pure application, it lacks of this immediate response. So this is one of the reasons we took to use that kind of curation of lots of data in our Kraken database. that reflects the second pair of rows. But we found that for big queries, also this approach was not interesting because the response time was very large. So the idea was to have a way to improve it. So Kraken is good for curation, consolidation, short queries, but is not good for online analysis processing, as you see on the second row on blue. So our idea is to use a fantastic product that is StarRox and Elasticsearch that runs very, very fast and gives you the possibility to do online analysis for all the research data, not only coming from Pure, but from the other ecosystem of data of our university. StarRox is an OLAP database that implements all the strategies to be a very, very fast database for analytics. Thanks to ByteByteGo for this kind of diagrams. So our landscape is Pure deals with API with Kraken and also gives to our data warehouse MicroStrategy all the data of our university. And then we use Flink and an engine of change data connection to know how data is changing at real time. For example, in this case is using the log file of the database. He's putting an eye on the log file, detects the changes, and does the queries to maintain completely synchronized StarRox database. And then StarRox runs very, very fast and gives you the possibility to do dashboards with the help of Apache Superset, very interesting product to do whatever dashboard you imagine in a very short time. For example, we give to the user a dynamic photo of the professors and researchers of a university in a way that also we have a little bit of dynamic building using, for example, this drop-down area to add more and more departments to know exactly the numbers they want. It runs in a sub-second manner, thanks to StarRox. Also, about money, this also también, also the, sorry. I am going on the bad direction, sorry. Okay, about money and also with a little bit of interaction about adding and subtracting areas of the university. This dashboard is running in less than 10 seconds and runs on the huge database of all the worldwide patents that is nearly 200 of millions of patents and near 1 billion of records about how patents are dealing and running and going in and out. This is another example of patents running in 10 seconds pace. Another example also. This includes calculus with applicants and owners, a very heavy calculus that runs like a charm. in less than 10 seconds. And this is the one that involves near 1 billion of records about that patents that go away or are being rebuilt or rebite or whatever. And the last part of my presentation is how we think we can use the research data in two projects. One about implementing a chatbot. The citizen is asking to the chatbot all the science that had been done in our university, and the other is a digital expert assistant to do the best document for the user and present it in competitive applications as the best document AI can help us to do. This slide has been rebuilt more than 4 times in the 3 months that we are doing this presentation, because the technology is changing very fast and we don't know how to use it and which part of the puzzle we want to use about vector database and which LLM to use, because they are changing fast. And we are running around those things. But the idea is to take all the papers, all the metadata of research that comes from CRIS and also from TUROS, of course, and all the patents, feeding the beast of the artificial intelligence and giving it the ability to talk with the user or the citizen about what we do on the Universitat Autonoma of Barcelona. Our scientists do. And this is all. I am finishing, and I give you more room for the questions. Only one slide to put the Hall of Fame of all we have done, this fantastic thing, and asking you remotely lots of thank you for your patience.
Please, a hand. Thank you very much, Jordi. So we were a little bit behind, but you went through this incredibly fast. So you can thank this gentleman that you have a coffee break later. We do have time for questions, of course. Does anybody have any questions to what you saw? There's one up here.
Thanks very much, Jordi. My name is Michael. I'm from SETU in Ireland. And I'm working now as research data analyst, but I used to work in the infrastructure group as well. So I'd be interested, when you build out your pipeline and maybe started prototyping the different Elasticsearch and so on, have you got access to your own infrastructure for virtual machines, or do you build it on the cloud platform? Or where do you build those components?
That was a very interesting experiment. We began using a couple of spare computers, very low power computers, 5 of them. We built a ridiculous cluster of 5 of them, and we put to use the StarRock's product on 5 of those, 4 of them on the back end and 1 of them on the front end. And also we put 2 nodes giving the second role of running Elasticsearch. We use Elasticsearch to do the text searches, because at that moment StarRock does it not support natively. And Elasticsearch is a very successful fork from Doris, Apache Doris, by the way. And this mix of Elasticsearch and the StarRock runs very well. We are asking to find the result over the millions and millions of abstracts of the patents, and it gives an answer in very low number of seconds. So it runs very well. Our idea is to jump to the infrastructure of the university when the model will be mature, and identify the number of nodes and the number of RAM that I think is the best point to know how much RAM we want or need to use.
Any other questions, please? There's time for one or two more. That does not seem to be the case. Are you sure? Okay. Thank you very much. The next session is the roadmap session at 11 a.m. in the big room again. There's time for a break. Thank you very much, Mr. Hernandez from Barcelona.
Thank you.